Congruence in overlapping triangles. Sometimes it can get a little confusing to decide which triangles we're trying to prove congruent because the segments and angles are overlapping each other. So as you can see in this diagram below, we have these three small triangles, but then you also have these two bigger triangles. So when it tells us that triangle ADC is congruent to triangle BCD, it's a little hard to see it in the picture. So the idea that we're going to use throughout this lesson is to separate the triangles so that we can better focus on the two triangles that we're talking about. So I'm going to take triangle ADC and I'm going to separate that and pull it out here. Now the key is to make sure that all of the angle markings come with the triangle exactly as they're marked in the picture. And then I want to take triangle BCD and I'm also going to separate that out. And again, make sure you take all the angle markings in the correct places and any segment markings that you might have. Now I know you can't use that function of the Smart Notebook to pull your triangles apart on your paper, but you can just redraw the triangles very carefully. Now, it tells us that triangle ADC is congruent to triangle BCD, but the issue is we have one pair of angles that's congruent and another pair of angles that's congruent, but that's it. So remember, we always need three pieces of information to say that the two triangles are congruent. But if you look carefully right here at segment DC, this segment is in both triangles. We have segment DC right here and then segment DC right here. And we've been using the reflexive property to say that any segment is congruent to itself. So when we mark that DC is congruent to DC in the overlapping triangles, now by angle side we can say that triangle ADC is congruent to triangle BCD. So we're just going to take that idea of separating triangles and identifying any common sides or angles as our first step in being able to prove these triangles congruent. So let's go ahead and practice that. So we want to take triangle ACB, so start with A, go to C, and then B, and then you want to retrace this. There's my triangle. And then I'm going to go ahead and pull that triangle out over here. So you basically want to redraw this sketch. And then we're going to pull the other triangle, PRB, from P to R to B. And again, I'll label the vertices. And then I want to separate this triangle out. Then lastly, we need to identify any common sides or angles. So here we don't have any common sides. AB is not found over here. CB is not found over here. AC is also not found in this triangle. But if you notice, both triangles have this angle B in full. So this angle is the common angle in the two overlapping triangles. Now I want you to go ahead and try this example. Separate the triangles, identify any common sides or angles, and then check back with me when you're finished. So hopefully you separated out the two triangles, triangle JKL, and then triangle MLK. And then when you pull those two triangles out, you'll see that segment KL appears in both triangles. So that segment is going to be congruent to itself using the reflexive property. Can we prove that triangle MON is congruent to triangle QOP in this last example? So let's start off with what we've been practicing this lesson, separating our triangles. So triangle MON, I'm going to go ahead and trace that here. We have triangle MON. And remember, we need to take any angle markings with it. And then we have triangle QOP, which is found here. And again, we'll take any angle markings inside of that triangle. So I'm going to go ahead and separate the two triangles. Now these two triangles aren't actually overlapping, but we do have this other triangle that fits in, and maybe that'll help give us some information. Because right now, in our two triangles, we only have one pair of congruent angles. And again, we need 3 pieces of information in order to prove that the triangles are congruent. So let's take a look right here in the center. Remember, whenever you have intersecting lines, or you find this X, you'll have vertical angles that are congruent. Now I'm going to mark it with 3 arc markings because we already have angles marked with 1 and 2. So these are marked with 3. Now it turns out that these vertical angles are actually part of the triangles that we separated. So angle NOM, found right here, we can mark with 3. And then angle POQ, found here, we can also mark with 3. So right now we have 2 pairs of congruent angles. We still need one more piece of information, so we're going to keep searching. First, let's go ahead and erase these marks from before so we can just focus on finding a third piece of information. Now this third triangle up top isn't part of the 2 triangles that we're talking about, but it will give us some information. So first I'm just going to outline this triangle, and if you notice, it has these congruent angle markings. Now when you have a triangle that has 2 congruent angle markings, that means that this is going to be an isosceles triangle. The converse of the isosceles triangles theorem says that when you have 2 congruent angles, then the sides that are opposite from them are going to be congruent. So that means segment NO is congruent to segment OP. You find segment NO right here and segment OP on this triangle. So now we have 2 pairs of angles that are congruent and 1 pair of corresponding sides. So these 2 triangles are congruent using angle, angle, side. That's it for this lesson. We'll get in some more practice with overlapping triangles in class.